initial condition at 0, right hand side in 0, so solution is 0. It is empty. It means that modal amplitude are 0, so modal expansion satisfies the causality principle automatically. And irrotational mode, it is interesting. Here is modal amplitude of irrotational mode, and right hand side depend on time. So solution should depend on time somehow. But classical time harmonic field concept says that irrotational mode are static field and nothing else. No, please. Here it is we had a source of electric kind, so we have some distinct from 0 right hand side of this equation. We have not source of the magnetic kind, so equation the simplest and initial condition at 0, homogeneous. So it is evident that B is 0, constant, if here is a constant. So static field. Indeed, static field, because we have no source of magnetic type. If we install in Maxwell equation source of magnetic type, situation will be similar to this one. So what we have? Our yes, and shortly the same, but in the case when Debye equation is involved in the Maxwell equation. So dynamic polarization is taken into account. So here is projection of Maxwell equation, here is projection of Debye equation. So I have here E electric modal amplitude and polarization vector. So polarization and electric field are coupled by the system of Maxwell equation, and of course the initial condition. Of course we need not initial condition in the time harmonic field constant. And this is for solenoidal. For irrotational mode I had one equation and one initial condition, and here is I have a pair projection of one of the Maxwell equation and Debye projection of Debye.